Excuse you.
So what we've been building up to here is graphing linear inequalities in two variables, which means we still have greater than, less than, not equal to, all that good stuff. But now instead of just having x, you got an x and a y. Just like every equation you graph that has both an x and a y, our goal is going to be to get the y by itself so that this is in slope-intercept form, and then graph it. So if I wanted to get this by itself, what would I do? I'd subtract x on both sides. We get y is less than negative x plus 7. Okay, so from this inequality, and we're just going to treat it like it's an equation for now. From this inequality, what is the y-intercept? It's the coordinates of the y-intercept.
It's where y equals 0, right?
Yep, so 0, 7.
Yeah.
And what's the slope of this? Again, treating it like an equation. The slope of the equation, meaning what's the number in front of the x? -1. Since it's helpful to have slope as a fraction, we could say -1/1. Now those numbers, the y-intercept and the slope, is all you need in order to graph this. So let's go to our graph paper. And we'll put 1 point on 0, 7. 2, 3, 4, 5, 6, 7. All the inequalities that we're going to graph tonight are going to be linear. So in order to graph a linear equation or a linear inequality, I need 2 points. So I need one more point besides that one. I'm going to use the slope to get it. The slope is -1/1. So from this y-intercept, down 1 and over 1, there's my second dot. If you really want to be a go-getter, you go down 1 and over 1 and put another dot for a total of 3. Not really necessary. Now here's the thing. When we did graphing on a number line, the way that we could tell the difference between a less than and a less than or equal to was by using a parenthesis or a bracket. Parenthesis for less than, bracket for less than or equal to. What's up?
Straight line or dotted line.
Yeah, it's a dotted line or a solid line. A dotted line is done for less than, a solid line is done for less than or equal to. So when I connect these dots to make my line, it's a dotted line like that. That's less than. That's the thing that tells me this was a less than equation. Okay? Now here's the part that's going to upset you. We're still not done with it because all I have shown is one line, and the solution actually is a bunch of lines. Less than means there's a bunch of lines that are below -x plus 7. So I shade this graph. I'm actually color in the graph. Either I will color in this part below the graph or this part above the graph, because I either want to say it's everything below this line, which would be all this stuff, or I want to say it's everything above this line, which would be all this stuff. How do I know whether it's above or below the line? And the answer is I pick a point on the graph that is not on this line to use as a test point. I'm going to test it with my inequality.
Okay, I'm a little confused.
Well, it's because we haven't done anything yet.
But okay.
Okay. I'm going to use the point 0, 0. And the reason I'm going to use 0, 0 is because 0, 0 those are really easy numbers to plug into an inequality. So my question is 0, 0 part of this inequality? Here's how I test it. I go back up to the equation, which was x plus y is less than 7, and I'm going to replace the x and the y with 0 and 0, because that was the point I used, 0, 0. So instead of x plus y, 0 plus 0 less than 7. 0 plus 0 is 0, so I get 0 less than 7.
It is less than 7.
Hey, 0 is less than 7. What the heck? That's true. That means 0, 0 should be included in my solutions. So when I shade this graph, I'm going to shade the part that includes 0, 0. I'm going to color this in.
The whole freaking thing?
The whole frickin' thing. There should be no white space. I expect this to be shaded perfectly. If you leave any part unshaded, you fail for the year.
No. Are we turning this in?
Or you can just graph it like I did. Just kind of scribble it like that. Every inequality you graph is going to look like this. Every single one. It's going to have a line, either dotted or solid, and it's going to have a piece that is shaded. So that was one that just had a less than symbol with no equal to line. Let me show you what the equal to ones look like.
So do we always want the y alone?
We always want the y alone so that it'll be in slope-intercept form, because slope-intercept form's easier to graph. Okay, so let's subtract the 3x on both sides. That seems good.
Negative y?
Negative y greater than or equal to negative 3x plus 4. And then we're going to divide by negative 1 so that the y will be positive. Very good. You guys are so smart. I should take back some of the bad things I've been saying about you behind your backs. So this is going to give me a positive y, positive 3x, negative 4, and the symbol in the middle flips because I divided by a negative.
So much for being
So much what? Are you whining?
This is the same as the first one, the symbol. Please ignore me.
Okay, no problem.
I'm rambling.
So now that I have this in slope-intercept form, what's the y-intercept?
3x minus 4.
That's the whole equation. What's the y-intercept?
Negative 4.
0, negative 4.
How do I tell? How do you tell that?
It's always the number on
The
the end.
x is the slope.
And the number in front of the x is the slope. What's the slope here?
3.
3. We want the slope to be a fraction, so we have the rise over run. So we'll write 3 is 3 over 1. And that is the information that you need in order to graph this. I need the y-intercept and the slope, because when I go to my graph, I'm going to start at the y-intercept 0, negative 4. There's 0, negative 4. But in order to graph a line, I need 2 points. So I need the second point by using the slope. The slope is 3 over 1. So from this point, I go up 3 and over 1. Up 3 and over 1. Now in this one, it was equal to.
It's a solid line.
So when I connect it, I don't do a dotted line, I do a solid line. And now the question is, which side am I going to shade?
Double.
Yeah, maybe. Let's find out.
0.
So 0, 0, I'm going to use as my test point. What I want to know is 0, 0 supposed to be in the shaded section? So I'm going to go back to my paper here. I'm going to go to this equation. 3x minus y is greater than or equal to 4. I'm going to replace the x's and y's with 0. So 3 times 0 minus 0 greater than or equal to 4. 3 times 0 is 0. 0 minus 0 is 0. Is 0 greater than or equal to 4?
No.
No, it is not. So 0, 0 should not be included in the shading. The other side should be. So I'm not going to shade the side that has 0, 0. I'm going to shade the other side. This is saying all of these points that I'm shading in, every one of these is a potential solution to this inequality. Okay. So maybe one of the questions you're saying is, can I just Can I always use 0, 0? Can that always be my test point? And the answer is no. So let's make sure we understand why we're using 0, 0 by doing an example where you can't.
And the solid line is a greater than equation, right?
Huh?
You know how the dotted line was the less than equation?
No, it wasn't less than or greater than. Dotted line was when it doesn't have the equal to mark. Solid line was when it does have the equal to mark. So like this one right here, see how there's no equal to mark? This one's going to be dotted because it's greater than, not greater than or equal to. Y is not by itself, so let's fix that by doing what? Why do you hurt me? Divide by 2. X divided by 2 is actually half x, and I'm going to write it like that so the slope's a little nicer. The way that this is written is weird because the y is on the right side instead of the left. You can flip it if you want to. Just make sure you flip everything. Y less than 1/2 x. If you flip it, you got to flip the whole thing. Okay, what is the y-intercept here?
1/2.
Yeah, there's no number added on the end. The y-intercept is 0, 0. What's the slope? 1/2. So on my graph, that's why I can't use 0, 0, because it goes through 0, 0. And then the slope is 1/2, so up 1 and over 2. Up 1 and over 2. Will I be connecting these with a dotted or a solid line? I forgot.
Dotted.
Dotted, because there was no equal to line here. So, there we go. And now the question is, will I shade above or below the line? I need a point to test, and I can't use 0, 0 because the line goes through 0, 0. I got to pick something else. Now you can pick anything you want to use as a test point that's not on the line. So if you're allowed to pick anything you want, let's pick something easy. Let's pick a pair of positive numbers. So I'm going to pick numbers up here in this quadrant. I want positives only, and I want low numbers. So I'm just going to pick like this one. It doesn't matter. That point that I picked there was 1, 2. I picked it because they're low numbers and they're positive. So I'm going to test 1, 2 in this inequality. X is 1 and y is 2. So replace the x with 1, replace the y with 2. So 1 greater than 4. Is that true? Is 1 greater than 4? No, it's not. So 1, 2 is not one of my solutions. I don't want to shade the side that has 1, 2 in it. I want to shade the other side. Okay? So that takes a lot of work, but doesn't seem too bad. I'm sure they're not going to get worse than that. That's pretty much, I can't even imagine what it would look like if it was worse.
Oh, you're gonna show us.
What? How dare you?
See, I thought this was easy. Now you're really gonna.
It's still easy. As a matter of fact, it's twice as easy because now you got 2 inequalities instead of 1. So last semester we did something called systems of equations. A system of equations is when you picked 2 equations and you found the point where those 2 equations intersected. Is this coming back to you? Where do the two lines cross? We spent 2 weeks on it because we did graphing, then we did substitution, and then we did addition or elimination. How do you find the spot where the 2 lines cross?
In order to pair solution of the system to satisfy both inequalities.
Sure. So Hooten's reading out of the book.
Yep.
I don't know that definition is as helpful as we might like. When you're solving a system of inequalities, it means graph both of them and what's the part where the shading overlaps. Instead of what's the part where the two lines intersect, what's the part where the shading intersects. So we're going to start off by graphing these like they were individual inequalities. I'm going to graph this one, and then I'm going to graph this one. I'm just going to...
Why is that for an empty right there?
Huh? Why is what?
There's no other little...
Bracket. That's just the problem.
No, this is the symbol that means these two go on the same graph.
Oh, okay.
So let's do 3x is greater than or equal to y first. Now that's already solved for y. It's just in the wrong order. So let's flip it. Flip it good. So what's the y-intercept here?
0.
0, 0. And what's the slope?
3 over 1.
3, which as a fraction is 3 over 1. Great. I'm going to go ahead and put that on my graph. The y-intercept is 0, 0. The slope is 3 over 1, so up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. When I connect these, will I connect them with a dotted line or a solid line? Solid, because it had the equal to. Great. Solid line. Which side do I shade on? Well, for that, I need a test point, and alas, I cannot use 0, 0 as my test point because it goes through 0, 0. So let's pick something else. This seems pretty good. That's close to 0, 0. That's 1, 0. Let's use 1, 0 as our test point. That's almost as good. So I'm going to go back to the equation. 3x greater than or equal to y. I'm going to replace the x with 1 and the y with 0. So this is 3 is greater than or equal to 0. True or false?
True.
3 is greater than 0. So that means I'm going to shade the part that includes 1, 0. You know, some people say math is hard, but I can't think of very many classes where you get to color. So you're welcome. Oh, shut up. You know, this is why we don't do fun things in here. Too negative. Too negative. Okay, let's try this one now. X plus 2y is less than or equal to 8. Unfortunately, that one is not solved for y, so we got a little bit of work we have to do. For example, I'll subtract the x on both sides. That seems like a good plan. So we get 2y is less than or equal to negative x plus 8. Then divide everything by 2. So that gives me y is less than or equal to negative x divided by 2 is negative 1/2 x and then plus 4. So what's the y-intercept? 0, 4. And what's the slope?
Negative 1/2.
Negative 1/2. So because this is a system of inequalities, it's on the same graph as the first one. 0, 4, right there. And the slope of negative 1/2 means down 1 and over 2. Down 1 and over 2. So this line's actually going to go through the shaded part, which is totally fine.
Oh, crap. I only have a black pen.
So you'll be okay. Just make it really, really dark. The part where it overlaps, make it really dark. Because that's what we're interested in, is where it overlaps. Okay, when I connect these, will it be with a dotted line or a solid line?
Dotted.
What was your second choice?
Solid.
Because it's got the equal to mark. Because it's equal
that's
to.
right. What it doesn't have is the dotted.
Correct.
Okay.
So solid line again.
Where's the other dot? Yeah.
Huh?
Where's the Yeah, where's the second one? I got the 0 4.
And go down
I went,
one. over
the
two.
slope was -1/2, so I went down
So
1 and
right,
over
two.
2.
Okay.
Now I need a test point that's not on that line, and I can actually use the same one here. 1, 2 was my test point. That one's not on the second line, so I can use 1, 2 again. Let's do it. So back here, x plus 2y less than or equal to 8. I'm going to replace the x with 1 and the y with 2. 1 plus 4 is 5. Is 5 less than or equal to 8?
Yes.
Yes, it is. So I'm going to shade the part that includes 1, 2, which is all of this. Now notice when I shade, there's a piece that overlaps. That piece that overlaps is important. I'm going to actually go over it really, really darkly. The piece that overlaps. It's this chunk right here. This is where the shading overlapped. Well, that marker didn't last long. It's where the shading overlaps. That part right there is the solution. The solution is, where's the part where the shading overlaps? So the really, really dark part, that's the solution. So it's just like a system of equations. We're looking for the part where they intersect. The only difference is in a system of inequalities, instead of one point where it intersects, it's a bunch of points where they intersect. That shading is representing lots and lots and lots of points. These two inequalities intersect at all of these points right there. All of those points would work for both inequalities. Meaning, if I picked any point in this dark section, any point at all, I could plug it into either one of these inequalities and it would work. It would give me a correct answer. That's what we mean by solutions. Does anybody have any questions about graphing inequalities in two variables?